This is an introduction to exterior angles. If this goes okay, then at the end of it you'll understand what the exterior angles of a shape add up to, and you'll understand how you can use that information to answer questions about shapes. Polygons is the fancy word, isn't it, for shapes from the Greek, I think, for many corners or many angles, I think. Exterior angles are the angles on the outside of a shape, and we can create an exterior angle by extending the lines of a shape. The first shape on this page is a square, and if we extend the horizontal side, the lower horizontal side, like so, then we can create an exterior angle there. And we can do the same thing up here, and here, and here. So we have 4 exterior angles on this square, and that's no surprise really, is it? Because we've got 4 interior angles. And we know something about the interior angles of a square, don't we? They're all right angles, right? And that will help us calculate the exterior angles here, because of course these exterior angles are all created on a straight line. So at each point, the interior and exterior angles at each corner of our square will add up to 180 degrees, because that's what the angles on a straight line add up to, isn't it? And you already know that. So if the angle on the inside is 90 degrees, then the angle on the outside will also be 90 degrees, or a right angle, won't it? Because 180 minus 90 equals 90. So we can see then that the square has 4 exterior angles, and they're all right angles. And that will tell us then that the total of the exterior angles here is 360 degrees. Okay. Beneath that we have an isosceles, not an isosceles, an equilateral triangle. I know it's equilateral because I've just put those marks on there to indicate that the sides are equal. There we go, it's cheating really, isn't it? But it works. Let's draw on some exterior angles to this triangle. Let's again start with a horizontal line and extend the line to the right. I could just as easily extend it to the left, like so, but I've just chosen not to. Extend it to the right, and we'll mark that angle there, and we'll extend that there and mark the exterior angle there, and down the bottom left there's our 3rd exterior angle on our triangle. 3 interior angles, 3 exterior angles. You ought to know by now that the angles inside a triangle add up to 180 degrees, and so the interior angles of an equilateral triangle, that's a triangle with equal sides and equal angles, will each be 1/3 of 180. And 180 divided by 3 is 60, so each of the interior angles of our equilateral triangle will be 60 degrees. And again, applying our knowledge of angles on a straight line, if each of those interior angles is 60, then each of the exterior ones will be 180 minus 60, which is 120 degrees. So there we go, 120 degrees there, and there, and there. In other words, we've got our exterior angles, we have 3 lots of 120 degrees. And 3 lots of 120 is 360 degrees. And you'll notice the coincidence there, and it's not a coincidence. You'll notice that in both cases, the exterior angles here have added up to 360 degrees. And that's not a coincidence, because, and feel free to do this at home, if you draw a whole bunch of shapes and get your protractor out, and measure the exterior angles of your shape. And it doesn't have to be a regular shape, it can be a shape with unequal sides and angles, but if you do that, you'll find that the exterior angle of your shape, the exterior angles of your shape, I should say, will always add up to 360 degrees. It's one of those rather lovely and beautiful things that you sometimes come across in maths. It's one of those rather nice and surprising rules. The exterior angle of any shape, no matter how many sides it has, whether it has equal sides and angles or not, whether it's a regular polygon or not, the exterior angles will always add up 360 degrees. So that can be helpful in a situation where, as perhaps here, you might be asked what the size of an exterior angle is. Here we go. If I say find x, you obviously want to do the funny thing of drawing an arrow and saying, here it is, because that always gets a laugh, isn't it? But that's not the right answer mathematically, is it? We can work out x mathematically by using that knowledge that the exterior angles will all add up to 360 degrees. So in actual fact, this shape, which is a pentagon, isn't it, 5 sides, has 5 exterior angles. Here they are. And of course they'll all be equal. It's a regular one, a regular pentagon, which this is intended to be. So they'll all be equal to x. So my 5 angles are going to add up to 360 degrees. Now I can write that as 5x equals 360 degrees. So in other words, if 5 of those angles add up to 360, each one is going to be equal to 360 divided by 5. And if I do 360 divided by 5, I get, well, let's write it out just in case you're not sure. Here we go. 3 divided by 5 doesn't go, carry the 3. 36 divided by 5 is 7, remainder 1. And 10 divided by 5 is 2. So each of those angles will be 72 degrees. Below that, we've got a hexagon. Again, it's intended to be a regular hexagon with equal sides and angles. And again, therefore, there'll be 6 exterior angles, and they'll all be equal. So again, if I have to find out what each one is, I can use the knowledge that they will add up to 360 degrees. So if they're all equal, then 6 of them, let's call them x, will add up to 360 degrees, and so therefore I can work out the size of each one by dividing 360 this time by the number of angles that there are. 360 divided by 6, and 360 divided by 6 is, of course, 60 degrees. So on our regular polygons, we can find the size of each exterior angle by dividing the number of angles, sorry, by dividing 360 by the number of angles, and that gives us the size of each one. We can also use that knowledge about the sum of the exterior angles to answer questions like this. If one exterior angle of a regular polygon is 36 degrees, how many sides does it have? If one exterior angle of a regular polygon is 36 degrees, how many sides does it have? Well, what are the important bits here? A regular polygon, I suppose, is an important phrase. A regular polygon is a polygon with equal sides and angles. In other words, if one of the exterior angles is 36 degrees, that means all of them are 36 degrees, doesn't it? And how many sides does it have? Well, that's important as well, of course. What do we know that the exterior angles all add up to? Correct, they all add up to 360 degrees. And if we're told that each of those angles is 36 degrees, then surely we can find the number of angles that there are by dividing 360 degrees, that's the total, by the size of one of those angles, which is 36. So if we do 360 divided by 36, that will tell us how many 36-degree angles there are. How many times does 36 go into 300? So how many times does 36 go into 360? Well, I hope from looking at that you can see the answer is 10. 36 divided by 36 will be 1, wouldn't it? So 10 lots of 36 will be 10. So I reckon that means there must be 10 sides. Think about it the other way. Let's check our answer. What is 10 times 36? Well, 10 times 36 is 360. That confirms our answer is correct, and that there will be 10 36-degree angles in our polygon. There we go. That's an introduction to exterior angles. You now know that the exterior angles in any shape add up to 360 degrees, and you've seen in a couple of examples ways in which you can use that information to help you answer problems on the subject.